This is Stephen Warrenberg with my final project for control of mechanical systems. And for this project, I built a cruise controller based off of the Tesla semi-truck parameters. My goal here is to have a controller that can maintain a set velocity, be resistant to noise, drive efficiently, have object avoidance, and be tunable and flexible. And my plan is to build the vehicle model, tune a PI controller to control that, add a moderation component to make it less responsive when it's going slower, um, add a set point weighting component, which would give me object avoidance, and then iteratively improve on my model. So the flow chart of my controller here, it flows left to right, but I have to build it right to left. So I have to make a vehicle model that the throttle position would be controlled by the PI controller, which has the moderation component I was talking about. And then a set point would be fed into that PI controller by the set point weighting component, which takes the given set point and the distance to an object in front of you and comes up with a set point to feed to the PI controller. So when I was developing the model, I just had some parameters that I got off of the Tesla website, and then also just like given air density, standard air density. So I was able to come up with the model, which is the force is equal to the mass times acceleration plus the damping coefficient times the velocity squared. And that damping coefficient is just from the drag of the air. And then also I made a power calculation based off of Tesla saying that they can get from 0 to 60 in 20 seconds fully loaded. And so then I took these parameters that I came up with and plugged them into this model, which is a model that I started with the model that was from homework 6, and then I changed it up to have it do what I wanted. So my parameters are in here, the power, the vehicle's mass, and then the damping coefficient. And as inputs, I can input the throttle position and also noise as a force. And as outputs, I get the vehicle's velocity, position, and the engine power. And then here, once I had the vehicle model, I was able to tune the power calculation a little bit because I had made some untrue assumptions to get started. So I did this based off of getting up to speed at full throttle in 20 seconds. And I realized I could give it a little bit more juice, which was good. From there, I had an accurate vehicle model, somewhat accurate, I guess, and I was able to start tuning my PI controller. So I just set up a PI loop here and had a set point of 30 meters per second, which is equal to 67 miles per hour. So to tune the PI controller, I put my truck through 2 scenarios. One is just accelerating up to the set point on flat ground from a stop. The other is accelerating up to the set point on flat ground, then going up a hill, down a hill, and then flat ground again. And from there, I was able to get PI constants, 0.2 for proportional, 0.01 for integral, and that gives me this response to the second scenario I just explained, which I was satisfied with. But I could keep iterating on this if I wanted to, but no need for now. So then one problem I have with the PI controller at this point is that I like its responsiveness when it's at maximum speed, but I don't want it to be calling for maximum power when it's going from 0 up to its set speed. So I need to add a moderation component to kind of dampen the response of the PI controller when it's at slower speeds. So that's exactly what I did. I made this responsiveness component and wrapped it around the PI controller. So now the controller is less responsive when you're going slower, more responsive when you're going faster. And so now this is the response that I get with that moderation component. And as you can see on the top right here is the power usage when you're accelerating from a stop without the moderation component. And then bottom right is the same thing, but with the moderation component. And you can see the maximum power that I'm asking for is about 90% of the max power of the engine, which is good. And I'm going from asking for like half power to 90% power instead of asking for 100% power. So that's a little bit more efficient. And then I could iteratively tune this also to make it perform how I want. And on on the left, you can see on the top is without the moderation component, on the bottom with the moderation component. You can see the response is just a little bit different. You're just getting up to your set speed a little bit slower, which is good because I don't want to be using so much power when accelerating. And then this is just the response to the scenario of going up and down the hills. You can see that the response is basically the same when you're up to speed and going up and down the hills, with the exception of when you're accelerating, you're just at the beginning, you're asking for less power, which is perfect. I want it to respond basically the same as the regular PI when you're going fast, but be less responsive when you're going slow. From there, I have the PI controller with the moderation component, being able to control the truck how I want when there's no objects around. So I get to do the fun part here, which is adding obstacle avoidance. So here you can see if there's an obstacle in front of the truck, which is the blue line, the yellow line, which is the truck, would just run into it if there's just a PI. So I need to add another component that will change the set point from the given set point to another set point when there's obstacles in front of you. So what I did is exactly that. I made this component which takes into consideration the objects in front of you and the given set point and comes up with a new set point. So when you're really close to an object, the set point just becomes the velocity of that object. And when you're really far from an object, you're mostly just working off of your given set point. And so now I have 4 scenarios that I put this the vehicle through, given this final controller, to make sure that everything's good. And I also use these scenarios to tune the controller. So here is the truck pulling up on a stopped object. On the top right, you see the object's position in blue and the truck's position in yellow. Top left is the set point in yellow and the truck's velocity in blue. And then on the bottom, we just have the power. So you can see here on the top right that the truck will perform like normal when it's on the open highway, but then when it comes up on the object, it will stop for the object. And here is a very similar scenario, but the object is moving slowly. It's not stopped, it's just moving slowly. So you can see that the truck is also able to come and pull up to a slow vehicle. This third scenario is a vehicle that it is erratically driving, so it's pretty violently oscillating its speed, and you can see that the truck can pull up to this vehicle and then follow it. The problem here being that the truck just tries to do exactly what the erratic vehicle is doing, which I would have to add another feature to make it back off of erratic vehicles, but at least it won't crash into the vehicle with this controller they have right now in its current state. And then this last scenario is an important but subtle feature here, is that if the truck pulls up on a slow vehicle and then that vehicle pulls away, the truck won't just follow that vehicle, because I had to add, at first I didn't have this saturation component, which would make the truck do whatever the vehicle in front of it is doing as long as it's close. So then if the vehicle was slow and pulled away, the truck would just follow it and actually exceed the truck's given set point. So I had to say, if the vehicle is close to you, but it exceeds your set point, we'll just stop at the set point and just take your given set point. So that's an important feature, to not be speeding away behind vehicles. And so from here, I have my controller, and the PI responsiveness moderator and set point weighting components could all be tuned to adjust how the controller acts. And then, like I said, I should add the function where it would back away from an erratic driver. And also I'd like to add a function that makes the truck slow down when it's approaching curves. And then obviously a driver would always be necessary to use this controller, and it's important for that driver to remain vigilant. So it's not like displacing the driver in this case. So that's it. Thank you for listening.